Hello friends, let us back to our topic in linear algebra, and in our previous two lecture we are properly discussed about the matrix and their properties, also some example of the matrix. Now in this lecture I want to discuss about the determinant and its properties, some example and so on. So let us start about the determinant. First of all, the definition of determinant. Let a ij A is equal to aij, which is n cross n matrix, be a square matrix of order n. Okay, then the determinant of the square matrix is denoted by determinant of a, or det a, or delta n, or delta a, or det of a. You can choose any one of them, and determinant of a is a scalar or constant number, and after determinant of matrix will get a constant number. Okay, now how to find determinant of a square matrix of order 1? If in a matrix of order 1, then it's looking like this is this determinant of a of order any element, any number is 2, so determinant of 2, that is determinant of 2 equal to 2. But for the matrix of order 2, it is a11, a12, a21, a22. Okay, and if we take determinant of this matrix, then multiply diagonally, that is a11 and a22 minus a21, a12, a21, a12, and this is the actual value. If we take an example, then a equal to 5, 4, 1, 2. So determinant of a equal to 5 to guna 5 to a 10 minus 4 1 a 4. That means 10 minus 4, that is equal to 6. Next, now some important result on determinant. Number 1, if we interchange any row of a determinant with column, then the value of the determinant unchanged. Means this 5 4 in row, so we want to change this in column. So 5 4 1 2 in first second row, so we want to change it in second column, so 1 2 is here. And determinant of these values is 10 minus 4, that is 6, and also determinant of this is 10 minus 4, that is equal to 6. Okay, next property is, if we interchange any row with row or column, then value of the determinant change by negative. What is the meaning of that? Means if we change this 5 4 with this row and 1 2 in here, that means 1 2 in upper row, that means first row, and 5 4 in second row, then the value is same but with negative sign. Okay, this value is 6 and this is minus 6. Next, how to find the determinant of a square matrix of order 3? Similarly, the rules of this finding the determinant is determinant of a equal to determinant of like a b c d e f g h I, the number of this matrix. So determinant of these values are, first of all, take first value. You can determine by any of these, by first row, first second row, third row, or first column, second column, third column. You can take any one and the value will be same. If I take the first row, then a into his cofactor, means e f h I, determinant of e f h I. So we know this is the second order determinant, that means ei minus hf, and a into ei minus hf, minus b, the value of the sign of this cofactor are this. For this value, this sign is positive. For this value, this sign is negative. For this value, this sign is positive. For this value, this positive. That is positive, negative, positive, negative, positive, negative, positive, negative, positive, like this. Okay, and similarly for this is for this b, the value is negative, so minus b. And for this cofactor means and this value is here, so left uh, so delete this row and this column, and the another values like d, f, g, I are in the determinant of order 2, that is d, f, g, I plus c into block these two row and column, this row and this column, so we get d, e, g, h, d, e, g, h. So after calculating we get this value. But also if we also there is a shortcut method to find the determinant of 3 cross 3 order matrix. The shortcut method is, first of all you have to write this matrix, the value, that is a, b, c, sorry, e, d, a, b, c, d, e, f, g, h, I. So a, b, c, d, e, f, g, h, I. Now again write these two column, that is a, d, g and b, e, h. Okay. Now our formula is, first of all diagonally these three element number you multiply and add, a, e, I plus b, f, h, b, f, h plus c, d, h, c, d, h minus same minus diagonally these three element of diagonally. Okay, g, e, c, this is g, e, c, h, f, a, h, f, a and I, d, b, I, d, b, or you can write b, d, I, b, d, I, a, f, h, a, f, h and c, g, h, g. Okay, and the value is same. Now an example, if a is equal to 5, 3, 2, 1, 6, 9, 2, 3, 5, then 5 into this matrix, that is you can calculate the value is 36. Okay, and by this shortcut method you can find this, see 5, 6, 7, 5, 6, 5, this 150, 3, 9, 2, this is 54, 2, 1, 3, this is equal to 6 minus 6, 2, 2, 12 to 24 minus 395 is 135 and 513 is 15. The actual value is 36 and both the value are same. Now how to find the determinant of infinite matrix? Are there is any method or shortcut method to find the value of infinite matrix? Yes. How? Now you have to see some pattern. Okay, like if it is determinant of square matrix of order 1, then this is like this. If it is of order 2, then this like this. If it's order 3, then this like this. So what we have to do, we have to get like an and n tends to infinity, then we get our actual result by the properties of limit. Okay, now some properties of determinant. First property, the value of the determinant remains unchanged if row and column are interchanged. Okay, the value of the determinant remain unchanged if the row and column are interchanged. Already I have done this. Second, if any two rows of a determinant are interchanged, then the value of the determinant changed by main value. What is saying, if any two rows of a determinant are interchanged, means this row and this row, if I interchange this two row, then the value of the determinant changed by the sign, means value is same but sign is changed. If there is plus, then minus. If minus, then it's changed by the plus. Next, if A and B are the square matrix of order same order. What? If A and B are the square matrix of same order, that is if it is 2 cross 2, then B is 2 cross 2. It is n cross n, then it is also n cross n. The determinant of A plus B you can write by determinant of A plus of determinant B in general. Okay. Next property is, if A and B are two square matrix, okay, then determinant of B you can write determinant of A to determinant of B. It's okay. Next, if each element of a row or column of a determinant is 0, then its value is 0. You know, we can determine by the any value, so 0, 0, 0 is obviously 0. Next properties is, each number 6, if each element of a row or column of a determinant is multiplied by the same constant and then added to the corresponding element of some other row or column, then the value of the determinant is same. Now it is a property, this is not necessary. You can go for these properties. If A is a matrix, B is a square matrix of order n, then K is multiplied with every element and of a determinant, and if we want to take this K common for all from all the elements, for all the number, then the order is in his power. This is K1, K5, K6, K9. Then this order is 2 cos 2, so you have to write K square into 1569. Okay. Next, if any two rows of a determinant are identical, then its value is 0. What is saying? That if any two rows of a determinant are identical, okay, two rows of a determinant are identical, then it is 0. Like A, B, C, A, B, C, D, E, F. These two rows are same, so the value is actually 0. Next, if each element of a row or column of a determinant is multiplied by the constant, then the value of the new determinant is K times the value of the original determinant. Like you can see here, if this is K into 5, 6 into K by 2, 3, then you can write this by K into 5, 6, 2, 3. That is, we have to take in common K from this first row, and K is multiplied by the determinant. And the last one is, if each element of a row or column of a determinant is expressed as sum of two row or more terms, then the determinant can be expressed as the sum of two or more determinants. Means each element of a row of a determinant are expressed as sum of two or more terms, like x plus y and z plus iota. Here A and B. Then we can write is x, z, a, b plus y, I, a, b. Okay, this is same. It is very easy, and here we want to stop, and will come to our next lecture. Here are some important result I have to read. Actually, I have made all the notes of linear algebra, just I have to deliver it, and some time is needed. Okay, till then, thank you.